Good afternoon to everybody. My name is Atul Dheer and I am a member of the PV Rooftop Cell formed under the EU-India Technical Cooperation Project Energy at the Ministry of New Renewable Energy in New Delhi. I welcome you all to this webinar on a very important topic of general and specific safety and its importance in rooftop solar applications. This is mostly a very neglected topic in the industry and in our usual practices. So we like to take care of it. There are several guidelines on safety aspects across the domain existing, but usually this particular practice is not implemented and it is not quantified and shared as a lesson. So I think we should not wait for any incident to happen and then act on it. This is the right time to do it. And we are joined by various installers, distribution company officers, state-nodal agencies right now who are joining in to participate and learn about this subject. And maybe if not learn, at least to recall about what we have learned, we have to practice in our daily life on this project implementation. So to start with, I will just invite our team leader, Mr. Marek Zaborowski at the EU Technical Cooperation to say a few words about the subject, and then we'll move to the speakers for the day. Over to you, Marek.
Thank you for giving me the floor. But before I will go to my subject, I will ask Mr. Himanshu to adjust the camera, because you are on the very bottom on the camera, so your face should be somewhere in the center. Thank you, sir. Thank you so much. So welcome everybody to this webinar. I just would like to highlight that this webinar is a part of our set of activities. We are providing similar webinars for DISCOMs already for a couple of months, and the webinar is also part of the training package which will be available very, very soon on the mobile application available from our website and also from the site of the ministry. I don't want to occupy much more time. I believe that we have the best possible lecturers here, and not only lecturers, but also we have representative of the stakeholders, and I'm very, very glad that we have with us Ms. Verelika Dubey from Uttar Pradesh. I believe that Atul, you will give her the floor. So start, and thank you for giving me this 2 minutes of time.
Surely, Marek. So before I invite the speakers and Madam to say a few words, because we have a lot of already attendees joining in, I'd like to highlight the subjects we're going to learn today so that I can move to the opening remarks. So today we are, I'm just like to broadly put across what we're gonna take up to this webinar. We try to understand the importance of safety and hazard assessment and safety training, the importance of all these aspects. We're trying to identify various safety hazards associated with PV systems and how to assess them and avoid them. We learn about different personal protective equipments commonly used for installing and maintaining the PV systems. The necessary equipment that should be installed for safe operations of PV systems. And at the last, we'll also learn about safety measures to consider while inspecting and visiting the PV premises. So this is really important because we have a lot of implementing agencies coming in. So this particular point is really helpful for them for the effective implementation of the program. So I would like to kindly invite now Ms. Verelika Dubey. She's the Chief Engineer, Demand Side Management at the Uttar Pradesh Power Corporation Limited. And she's also the nodal officer for the Rooftop Phase 2 program which is being implemented in Uttar Pradesh. Over to you, madam.
Yeah, thank you, Mr. Deep. And hello, everybody. Are you listening to me?
Yes, madam, you are audible.
This is clear. Okay. So it's a pleasure for me to join all of you, to be amongst you in this very, very important webinar. that is going to highlight the safety features that are generally neglected in normal working, and it will focus on solar PV installations. I, in fact, I will congratulate European Union India Technical Cooperation Project Energy for raising such a good platform and for giving such a important training, because I was going through the Google and all, and I found that there are serious hazards. There are serious accidents like fire and other accidents, like there is loss of human life also for many places. I have just gone through Google and found all this. So I realized that this is definitely a very, very important thing to be observed while installation and even during operations of the solar PV installation. Because see, the human life is involved, safety, other hazards are involved, and on top of everything, your reputation of your company is also involved. If you are just giving such a system, such a poor system which can create hazards and loss to human life, how long will you sustain? This is the question. This is why every installation, every installer should give topmost importance to this. Um, as I know, I hope everybody knows the panelists, Mr. Himanshu Desai from Gujarat Energy Management Institute and Mr. Yoginder Verma, MD, Center for Health, Safety and Environment are amongst us. And I'll make not to just elaborate on the safety features and all these things here. Personal safety of the installer also is important. Like all of us during this corona crisis are seeing that even PPE kits for the doctors are not available. So at least be very sincere to keep your installers safe during their operations. And I will also thank Mr. Marek Zobrowski to give us a chance to be in such a wonderful session. I'll not take much of your time and invite our panelists to continue. Thank you, Mr. Deal.
Thank you so much, madam. You rightly said about the personal protective equipments. We are really into crisis. Everybody is seeking for PPEs at the moment. Everybody is trying to get the PPEs across the country. And I think when we really realize the importance of PPEs in our health department in the country now, we should also realize we need it in our industrial practices and also in the PV domain. So to start with, I'll just quickly introduce to our speakers. To start with, Mr. Ugender Fani Verma. He is the Managing Director of Center of Health, Safety and Environment, Hyderabad. He is a certified associate safety professional by the Board of Certified Safety Professionals in the United States. And he has been working in the safety industry for almost 10 years. He has a lot to share with us. So he'll be talking about general safety aspects today with all of us. And later on, we have Mr. Himanshu Desai, who is a technical officer at Gujarat Energy Research Management Institute. Himanshu is in charge of the solar laboratory at Germany. He is a master trainer of Solar Skill Council for Green Jobs. And he has an experience of execution of 700 megawatts of solar PV in the country. And he has also trained 3,000 individuals, a huge number of individuals. Himanshu is also working with us on physical training programs we are organizing in our allocated states. So Himanshu will be taking care of the specific safety segment of our webinar. So I'll kindly invite Mr. Ugender Verma to share his screen, and we'll start with you, sir.
Okay, so anyways, hi, good afternoon. It's Nice to meet you all in this short safety webinar. So, as Mr. Atul has explained the importance of safety, and even Ms. Varlika Dubey has explained the importance of safety. So, today we are going to see how are we going to manage the risks, how shall we identify the hazards, and we'll be looking at what precautionary measures will be taken while we are installing this rooftop solar PV. Okay, so without any delay, we'll be entering into the content. Okay, so fine. So before starting our presentation, we'll see why safety is important. Okay, so this short video clip will let you know the importance of safety. So as you have seen that safety is important, just the video says many things. So why is it really so important? So it is the time that we ask ourselves, why is it so important? And first of all, what is the safety? Safety is just nothing but, just keeping the people safe. So if you do any activity, so the persons or the employees shall be free of injuries or free of illness. The environment shall be free of any environmental damage. At the same time, your asset or whatever property you're working on, it shall be safe. Okay. So if we are keeping all these things safe, then we can say that yes, there is safety to that particular premises or your workplace. Okay. So similarly, now the next question is, can we really take chances? No, because you know that our luck is not that strong. Okay, so we cannot really take chances. So why should we take chances? Okay, it's always better not to take chances and follow the procedures laid by the regulatory body or your company. Follow it and just then be safe. Okay, so if you are an employer and you have employees working at your company, okay, first say an example, you have your employee working at a site and he has a fatal injury. So can you really be so sure to approach the victim's family and say that, see, your husband or your your brother has been working there, your father has been working there, your husband has been working there, and I'm so sorry to say that he has been into a fatal accident. It is not so easy, right? So going and approaching a family, approaching a victim's family or an injured person's family and stating that your so-and-so relative has been injured, it's not so easy. So what is easy? What is easy is following safety is very easy. So what is meant by following safety? We have certain procedures, we have certain rules to follow. Okay, so we follow those rules, okay, and we be safe. Okay, and I don't say that following rules will make us safe, because these rules are made by our past histories and past experiences. So even there might be some gaps in the procedures that we are creating. But that is the reason we should never take safety for granted. We keep on assessing ourselves. We keep on assessing ourselves, assessing the hazards, assessing the current scenarios. We change our procedures. By changing our current procedures, we stay updated, and then we can be saved from the greater event from occurring. Okay, so safety is for everyone. It is not for just for companies, not for employers, not for just stakeholders or for users. It is for everyone. Okay, whether you are at home, whether you are at road, whether you are at your workplace, so safety has to be followed everywhere. Okay, right. So now we are going to discuss how we are going to manage safety at a workplace. So is it really difficult to manage safety at workplace? And I say no, because it is very easy. It is pretty simple. Only thing is you need to know how. If you need to know, if you know how it is done, and it is very much simple. Okay. So implementing safety in a workplace, you need to have a set of guidelines set up. You need to have a certain system in place. If you keep that system in place and you follow it, then you can be sure that safety is implemented properly. So how do we establish this particular system, or how do you establish this setup? Okay, for that I have already listed out that these elements, okay, which are required to implement safety in an organization. So we need a policy. What is a policy? We are framing a policy to make sure that we are committed to implement safety in our organization. For example, say my policy is not to smoke or not to have alcohol. That means I'm committed of not having it, right? So that gives a commitment. Okay, that shows the commitment for a particular organization that yes, we are committed to implement safety. And what's next? Then we need to have a plan. So what are the activities that are being undertaken by that particular organization will be listed out, and how, what arrangements will be taken, what are the organizational aspects that we need to see. So how do we achieve our set goals and targets? So in order to reach that, we will be establishing ourselves within plan. We call it HSE plan. HSE is nothing but health, safety, and environment. Okay, and then we have to conduct this hazard and risk analysis. Okay, in short, it is HERA, or we say we have a module of hazard management. Okay, so we need to have this risk management or hazard management as a module in your management system. Similarly, you have incident management, where you collect the data of past incidents, present incidents, you analyze it, whatever the recommendations are given, we have to implement it, and we have to make sure that after implementing these particular recommendations, such similar incidents will not occur in future. So that is the purpose of incident management. And we have occupational health and hygiene, where we analyze the health-based risks for your employees. If they are exposed to your chemicals, they are exposed to heat, you are exposed to some illnesses. Okay, so we're going to identify that, and we are trying to make sure that Yes, employees are safe from occupational related illnesses when they are exposed to certain particular chemicals, or it might be some other infectious diseases. If it is a word of infectious diseases, now the whole world is talking about corona. So even in occupational health, we have certain things to look into. Okay, similarly, fire prevention and protection. We have environmental management, emergency response planning. We need to know how to save a person if he's really into some sort of some sort of event. Okay, and then permit to work. Then we have trainings to give. We have several trainings. It depends on the nature of work we are doing. It depends on the requirements. If we want to improve the competency of any employee working in our company, then what we should do, we should train him. We train him for once every 6 months. And whenever I say training, they say, sir, do we really need to bring a third party person to train people? I say, why? An employer, he has established his company, he certainly knows, he has studied, so he can deliver trainings by himself. Just he need to provide some basic things. Only if it is really necessary, if a technical advice is required, then you bring a third party person for training, right? So there are many things that we can do by ourselves, especially for safety. You don't have to go in depth, go and give in depth training. So small basic awareness kind of sessions is much more, enough, because no worker is willing to die for sake of a company, right? And no one is willing to take risks. So who will take risks? So no one will put their life in front of other person's lives. Okay, that's reality. So normally the concept of safety is always in our mind, but sometimes what happens is we are likely to take risks. So having this management aspects, or having this particular system in place, will make sure that even though there is a chance of person taking risks, he will not deviate from the existing system. That is the purpose of your managing safety, okay, or your management system. So to do that, we need to conduct audits, we need to conduct inspections. This is a part of monitoring we have. And then we review our procedures as per the regulations, or if you're having too many incidents, or if you're not achieving your set targets and objectives, then we review the whole system. Okay, so this is the basic elements of what is required in your safety management system. But apart from that, if you are willing to have an ISO 45001, which is previously OSHA's 18001, which gives a safety framework, which is the Occupational Health and Safety Management System framework, which ensures that the system is reliable, and easy to implement. And specific guidelines, a clear set of guidelines are given in this ISO 45001. By implementing that, you can make sure that your organization is doing good in your safety. So what are the other missing elements other than what I have mentioned here? The missing elements are, you have to measure performance. Measuring performance can be done by audits and inspections. It is covered in the topic. But apart from that, we need to have document control as per ISO standards. So, hardly a couple of other elements are missing. But apart from that, if you have these particular elements, that would be enough to implementing safety. But implementing safety certainly comes with a cost around it. Okay, certainly there is some sort of cost involved in implementing safety. So what about certain new startups or people who does the work on their own? So we don't really want to frame such a type of management system, but we need to be safe while working. So what should we do? Is it really necessary? No, it is not necessary. But it is always better to have a policy, plan, and risk assessment. If you have these three things set up by yourself, that would be sufficient, because you just need to know that you have identified the risks and I'm controlling it, or either I am mitigating it or controlling it. So that is important. So you establish only 2 procedures or 3 procedures which is really required, and that would be sufficient. Okay, and you no need to go for any certification, because certification costs a lot. And second thing is, what I suggest is, if you are really true to yourself, you are following safety to yourself, and you're committed in following safety, then what is the purpose of certification? It is just to showcase that yes, we are following that standard. So that is not really required when you are following safety to yourself. Okay. So what is important is, it is not how we do it, it is what we do it. Okay. At the end, we are safe. That's all it matters. Okay. We are safe. We are keeping others safe. That's all it matters. Okay. So really, ISO 45001 certification is just showcasing that yes, you are implementing safety. Other than that, nothing much. Okay. So if you really want to manage safety, even for small organizations or big establishments, doesn't matter, as long as you're identifying hazards and mitigating them, and you're taking proper risk controls. Okay, right. So in ISO 45001, it's always emphasizing on continual improvement of your management system. So how do you do that continual improvement? So we have a cycle which we call PDCA cycle, or in short, it is a PDCA cycle, which is plan, do, check, act cycle. By following that, we continually improve our management system. So what in every stage, what do we do? In planning, we establish our policy plan. So while establishing our policy, we set our goals and targets, and we'll try to achieve them. And how do we set our goals and targets? It is entirely dependent on your organization, or on what aspects of safety you're looking into. It totally depends on that. And we plan on how to procure our resources, how to arrange all these things. Okay, like we need PPE. So these are the resources. PP is the resources. Anchoraging points are the resources. So in the training, we will be discussing about specific rooftop safety. So I think we'll cover more points over there. And then do. So in do phase, we will implement whatever we have prepared. Whatever we have put in paper, we will be implementing it. So we will implement. We'll conduct this hazard identification risk assessment. We will implement the controls. We will implement the incident management plan. We will have emergency response preparedness. Preparedness is very much important, because if something happens, we will be quick to respond and we can save other person's life. And we will see how can we do that. Okay, specific to working at height, we will be discussing on that point. Okay. Next is we have to check. That means we have to measure performance, or else we don't know whether we are going on a right track or we are deviating from a track. So we just need to continuously check. How do we do that? Based on the reports, based on the accident statistics, based on your performance, like you have your daily inspections, you have monthly inspections, you have weekly walkarounds, depending on the organization and the type of activity that you are performing. And you have audits which will be done once every 6 months or once every year, to make sure that yes, you're following what you are intended to do. And then you need to act. What do you need to act on? You need to act on the recommendations that are given by the audits, or by the risk assessments, or by the incident investigations reports. So whatever the recommendations we are getting, we need to implement that. We need to act on that. If we see that there is a gap in the system that we have created, then we need to fill that gap. So we have to revise all the procedures. So we again go back to plan. We change our procedures, then we come back to do, we come back to check, and then we act again. So this way, it is a continuous cycle where we improve our management system continuously. Okay. Yeah. So one thing that we should make sure is, employer's part is to provide all the facilities like PPE and a safe workplace. And employer's responsibility is to make use of those resources properly and then work carefully. So normally incidents occurs because of unsafe acts and unsafe conditions. Unsafe act is an act, it is because of a person's action. Okay, person doing a work. Okay, he might commit a mistake knowingly or unknowingly. That is different, but ultimately the result is incident. And unsafe condition is something which is existing. For example, say heavy winds or hot temperature. Okay, because of that a person has collapsed. That is because the cause is hot humid conditions. So the weather is a culprit there. So it is unsafe condition. So what we should not encourage in a workplace is an unsafe work behavior. So by seeing this proper clip, and you'll be able to know why we don't want unsafe work behaviors at work site.
to work. Go on.
So I hope you like the video. Thing is, you should not work in this manner. Okay, this is completely unsafe work behavior, and we should not encourage such things to happen in our work sites. We have to work very responsibly as far as safety is concerned. Okay. So now we look into the next topic, which is hazard and hazard identification and risk assessment. So first we'll see what is a hazard. Hazard is anything which has the potential to cause harm, a simple definition. But what exactly is it? So it might be any situation. It might be any kind of action, situation, scenario, or any source which has the potential to cause an injury or illness to any person, or it might even damage the asset. Okay, so that is a hazard. So until and unless we are in contact with the hazard, there is no harm. Only if we go and we contact a hazard, then there is a harm. For example, take electricity. Electricity, as long as it is in the wire, it is in an insulated wire, there is no harm. What if we go and touch it? What if there is no insulation? Then we has chances of shocks or short circuits. Okay, so then the hazard arises and it causes an incident. So hazard by itself is not problematic. Hazard, when in contact with something, becomes problematic. Okay, so how do we control these hazards? To control these hazards, it is very, very important to identify them. So how do we identify them? We can identify the hazards by spotting them. First, we have to spot the hazards. So how do we spot them? So before spotting them, we should be aware that such an hazard exists in a work site. How do we know whether such an hazard exists in a work site? So it comes from trainings, it comes from different materials, it comes from operation manuals, it comes from manufacturer's recommendation. So by seeing all these documents, or by conducting risk assessments, or looking at previous incident scenarios, we will be able to know that yes, such kind of hazards might exist in my work activity. By identifying that, we will be able to take some control measures to prevent some event from happening. Okay, so here, in order to identify hazards, apart from the normal documentation, we have a simple concept of human, okay, by ourselves, by human perception, we can identify hazard by using our senses: look, listen, and feel. We have to carefully observe the premises by our eyes. And second thing is we have to listen. For example, if there is any high noise, if there is any vibrating instrument, if there is any loose bolt, you'll be able to identify. So you have to identify the noise, and you have to feel the hot temperature. You can feel the hot temperature easily. You can feel the coldness easily. Okay, but I don't say you have to sense. Okay, you should never rely on your nose, because if it is a toxic gas, then it can kill your nose senses, and you cannot rely on your nose. But look, listen, and feel through your eyes, okay, through your ears, and through your whole body, through skin. Okay, by this you will be able to identify hazards. More or less, safety is just a common sense. You need to know, okay, if this is the situation, what might happen, what might go wrong. You need to identify what might go wrong, then you will be able to find out your hazard. Okay, right. Now in this picture, try to identify the hazard. Now here two people are working, one person is on the ladder and one person is on the cable tray. Certainly there is a deep excavation or a deep trench in which they are laying cables. So what are the hazards, what might happen? Okay, so if you see, I'm just given only a few examples here. First thing, working at height. They are working at height, so that's a hazard. They are working inside the trench. If a person falls, it falls into the trench. So the depth is more. Okay, so it's a deep excavation or a trench. And ladder is placed inside the loose soil. What if it loses the balance? What if the person overreach? Okay, the ladder is also not placed well. It is not tied to the rigid structure. And the person who is standing on the cable tray, he might also fall at any time. There is no proper access or platform for the work location. So these are all the hazards. So in order to save these two people, what should we do? If he is given a proper platform to work on, then he'll work carefully, right? In order to save him, certainly it comes with a price again, like I said. So we need to give recommendations depending on the activity, the type of hazard we are dealing, the degree of the hazard. Okay, that is the degree of the hazard. We will see how we will evaluate and what is the importance of evaluating a hazard. We will see there. But for now, it is the degree of the hazard we need to see, and the severity of that hazard. Okay, it might cause it might cause a grave injury, severe injury, or a fatal injury. We are just going to try to identify that, and we are going to take precautions accordingly. So only if you will be able to spot hazards, you will be able to do that. Okay, right. Now what's wrong in this picture? Now here there are many people working, they are working in a very limited places. I know that having PP, if I say kindly wear a helmet, kindly wear a safety shoe, or kindly wear a gloves and go inside and work. They're using sharp tools, certainly, because it is cable blending and termination. So if I say that you go inside and you do work, sir, I'm not able to insert my head inside because it is very congested area. Yes. So there are some cases where we cannot provide all sorts of controls. In that cases, we have to isolate or eliminate the possible risks. What are the possible risks? We have to identify and we have to eliminate them. But as far as this picture is concerned, there is no proper access and egress. Work location, they are working without any proper protective equipment. Okay, there are certain tools. I don't know whether they have inspected those tools before and after use. Housekeeping is not proper. So certainly they are working, so after work they have to do the housekeeping. So these are the things that we have to always take care of. Okay, and what's wrong in this picture? I see an earth connection being tested. I think it is a megger. So normally we know that we apply like 2.5 times voltage or for the megger test. So it's highly dangerous again. Okay, so there is no proper PP. There is no, people are not following any standard practices. I don't think there is any standard practices built up. So these are the things that we should really take care of. Okay, ultimately, if our employees are good, then they will be much more productive. But I know immediately if we say, okay, these are the procedures we are going to implement and you should follow them. In the beginning, it will be a bit difficult, but if they get habituated to the procedures that you have created to be safe, and certainly they can work properly. Okay. So these are some of the best practices where you can see the persons working on a rooftop installing a solar panels. They are having full PPE. They are hooked to the hooked to the lifelines. They are having gloves, helmets, and safety shoes. They are working very carefully under the supervision. Okay, so I mean these are the best practices that you can see in this picture. Okay. And here are some of the other best practices where installation is being taken care, and even they are having full PPE. Okay. Even here, you can see that there is an A-type ladder which is placed, and the person is trying to reach, and he is following all the proper safety standards because the A-type ladder is on a leveled surface. It is not an unlevel surface, so that is a best practice that you can see here. Okay, so in this three presentations, if you see, I have emphasized on PP, PP, PP. So now there might be a question. So just by having PP, does it mean that you're safe? No, just by having PP, you're not safe. You need to, there is much more things that we need to do to be safe apart from PP. PP comes last. So that's what we are going to discuss when we are going to discuss about PP. Okay. Now, as we have seen this hazard identification, now we're going to see risk assessment. Okay. So what is risk? Risk is nothing but likelihood of harm arising from the hazards and severity of it. Okay. So risk is probability into severity. Okay. Probability of the hazard from occurring and the severity of the risks. By calculating this, we will get risk. So what is risk? What is the connection between hazard and risk? Risk is an evaluating tool. It is just like our calculator. It is calculating the degree of hazard. That is what we have discussed previously, right? Degree of hazard. It is calculated by risk. If we say that there is high risk, so certainly we know that the danger is high. If we say it is low risk, then you can take some calculated risks. So do we need to take that calculated risks? Yes, I am going to explain that in a moment. Okay, so hazard is an risk is an evaluating tool for hazard. Okay, so how are we going to evaluate? We are going to see the probability of that hazard from occurrence, and if it occurs, what is the severity? For example, say there are two wires, one at a door level, one at a cellar level. Though both insulation is open. Okay, so what is the chance that I go and hit it? At a door, it is more. So the probability is more there. So getting a shock is same. If I get a shock, what will happen is next. Okay, but we will consider it as a severity will be high because getting shock itself is very high. Okay, because 0.30 okay amps is very lethal. Like 30 milliamps is very lethal to heart. 35 milliamps is very lethal. So that is why we will have ECLBs and everything tripping at 30 milliamps. Okay, so normally we have 230 volts. Even if it is 1 kilowatt, we have 4 amps flowing through that particular conductor. 4 amps is too high. What if we get a shock? So the risk of fatality is very high because 30 milliamps is lethal. Sorry, 35 milliamps is very lethal. Okay, so now the probability when the wires are near to the door is more and the severity is more, then I say my risk is more. So if my risk is more, what should I do? I have to immediately implement some controls. What will be the controls? Insulate it, cover it, or terminate it. Whatever the work is has to be finished. Finish it fast and close it, or isolate and make sure that there is no electricity flowing through the wires. So these are all the things we'll do. But if it is on the ceiling, okay, there is no hazard because there is no probability of me going and touching there until and unless I have some task over it. Right? If I am having a task, that means I am aware that there is some electricity into it. Correct? So the probability of me getting in contact with the hazard is less. But even though it is less, if I get a shock, the severity is more. So in order to even remove that, what I will do, I'll put a normal control measure, just insulate it. Whenever there is work, I'll go remove the insulation, do the work and come out. So the control measures which I am determining is based on the risk level. If the risk is high, my number of control measures will keep on increasing. It keeps on increasing until the severity of high becomes low. Because Now, if I say we have some hierarchy of controls, we call it. We have hierarchy of controls. So in short, it is ERIC PD. We say first you have to try to eliminate the hazard. If not possible, then you have to reduce the hazard. If not, then you have to isolate it or else control. Next comes PP. So PP is the last resort. So we'll discuss why in the end of this session. And then comes the disciplinary procedures, your procedures. So if I say electricity is a hazard, I say, okay, eliminate the hazard, remove the electricity. Will you be able to work without electricity? No, not in this world, right? Not at this times. Certainly we need electricity for everything. So there are many places where we will not be able to eliminate the hazard. So hazard is always existing, but how do we work along with the hazard is what we are trying to find out. So we have a concept of LR as low as reasonably practicable, where we bring down the severity of risk. We'll bring down the risk rating from high to low by giving too many controls, okay, by giving too many layers of protection, and we will reduce the risk to low. And we will make sure whether this particular low risk is acceptable or not. If it is acceptable, then we will continue working with the control measures that we have already given in the risk assessment. So this is the process of your whole hazard identification and risk assessment. Now, but what are the steps to do this hazard identification and risk assessment? Now we have an activity. You have to take an activity. For example, installing is an activity. Installing rooftop PV system is an activity. Now in this activity, there might be many sub-activities. So we have to take each and every sub-activity. In each and every sub-activity, we have to identify the hazards. Once we identify the hazards, what we have to do, we have to find out the risk associated with that particular hazard. Once we identify the risk associated with that particular hazard, then comes the control measures. And after finding out the control measures, we have to make sure now whether the risk rating is low or not. Because even after giving control measures, if the risk is medium or high, then there is no your purpose is not solving of having your control measures. So what we will do, we'll try to put some more control measures and make sure that the risk is low. Okay, and we will find out who is the responsible person in implementing all these risk controls. Okay, why are we doing this? Because we have to find out the hazard and we have to restrict it. Having a document will serve the purpose. If not here, it is, it can be used across all your installations. Once you have done this risk assessment for one time, and you can use this document everywhere. This can be useful, for creating awareness. Okay, it can solve the purpose of your safety related activities. Okay, risk assessment can be used in many ways. Okay, so now here in the process of hazard identification and risk assessment, we are conducting this particular process of risk assessment twice. First, after identifying hazards, we are finding out risk. That is called initial risk. Okay, after finding out the initial risk, we are again giving control measures, and then we are doing our risk assessment again. So we are conducting this risk assessment twice. Okay, so the first time risk assessment is called initial risk. Second time, whatever the risk assessment we are doing, it is to find out the residual risk. What is this residual risk? After giving control measures, whatever is the leftover risk is called as the residual risk. Now, if we are accepting that risk, we say that, okay, this particular control measures is okay. Because if you keep on adding your control measures, again, your cost will be more. Okay, for say your 100 rupees activity, we cannot really spend 120 rupees of solution for control measures, right? So it all depends on these many aspects. I mean, cost related aspects, and the solving the problem. Okay, in a limited measures, sometimes you won't get what you wanted. For example, say if I say, yes, you need to completely restrict this hazard, and I need so and so resources to bring and implement it. Sometimes you don't find a resource, then what will you do? You look for an alternative. So whatever is easiest means of implementing, the easiest means of implementing to keep it safe, that is what we are going to find out. Okay, and what are the requirements to conduct HERA or JSA? So in order to conduct this HERA or JSA, Certainly you need a document called work method statement or method statement, which specifies step-by-step job procedure, A simple, you can say, what are we going to do now? What tools are we going to use? What precautions are we going to take? I mean, what sort of PP are we going to use? The same will be mentioned in the method statement. By having the document as a reference document, we will be conducting this here. Okay, so after this here is done, we have to get approval from all the related parties. I mean, for example, say certainly not a manager or your client is not going to do this risk assessment. So you just need to get it approved. If you need to make sure that yes, things are in a proper place or things are being done in a correct manner, because it is not like we have the complete knowledge of risk assessment. So it is a team activity in normal, but when there are no resource, even an individual or a person who knows about conducting risk assessment can do it. But normally we recommend it being a team. So a couple of people or a person or a team of 3 or 4 from different backgrounds related to that particular activity can come up and conduct this risk assessment. Okay. So next we're going to see the example how the HERA looks like. Okay, so this is a simple activity of constructing a wall, where for example there is a wall construction. I'm just giving an example. There might be a number of activities involved. So just to make sure that you understand the basics of risk assessment. So we have taken an activity of wall construction where the job where we have to divide the job into job steps. First job of shifting and brick material, and second job is construction of wall. And we have identified hazards for each job step, and we have identified the initial risk, then controls, then the residual risk, then who is responsible for that implementing the risk control. See, as you can see, my initial risk is medium, and ultimately after the control measures, I have brought my medium risk to low risk. Okay, so this is the ideal HERA, I can say, or the format which we can use, very simple format. And we have many software applications or tools have come into this times where we can use, and it really becomes easy for us to implement the system. Okay, be it your management system, means risk management system, it is very easy to use it. A simple tool, install it, and everyone can use it. Okay, right. So with this, we are going to end our topic hazard and hazard identification and risk assessment. We'll head into the next topic. Okay. So now we are going to see what are the hazards in rooftop PV system. Okay. So in this hazards in rooftop PV system, now we have taken 3 phases of installation. One is pre-installation, installation, and post-installation stages. In pre-installations, first thing is you're going to bring your solar panels, inverters, your connectors, cables. You have these frames, metallic frames. You bring all the materials, you transport them from various locations to the particular work site. Okay, so when you're bringing this, there is a chance that you get damaged because of the transportation issues, or might be of the components being of low quality. So things you need to check is, I mean, these are the really hazards, because if you get a low quality component and you install it without seeing, because we have no other means to check it at site, so you just install it. And you have to be very, very careful so that there will be no loose contacts, or there will be no loose termination. So once you get all the components, you recheck it for the damages, and then keep it at site, and you can be good to go for installation. Okay, you just keep all the QC reports. If you are having an inverter, or a transformer, for example, say you need to do this short circuit test and open circuit test. You need to keep all those reports so that you can be sure that yes, this particular equipment that you're installing is good and it is quality tested. Okay, similarly, you have quality certification or testing for everything. You need to keep all the reports, and make sure you have all the manufacturer manuals or recommendations with you at all times. Okay, right. The main thing is transportation. You have to choose your transportation very properly, because I know that most of the people will be using this Hydra and normal trucks, and where people don't secure things properly, as you have already seen in the first video, importance of safety video, where people don't secure things properly. Okay, So try to secure things, secure it, and make sure that your load is not coming out of your truck or your vehicle. Okay. So that's the main hazards in pre-installations. So once you get all the material, then you are good to go with the installation. In installation stage, you have too many hazards. Okay, so I guess before installation, you will have a small site assessment. So while conducting the site assessment, you will be knowing where exactly you're going to install it and how are the premises, and whether there is edge protection to your rooftop. If you have an what do you say, perimeter surrounding it, if you have a guardrail system already existing to the particular rooftop. So all these things we can assess. If you feel that no, it is open and there is no guardrail system, normally guardrail system consists of a top rail, mid rail, and a toe board to prevent people from falling. So I mean, if not such a system is not existing, then we have to create our own means. And if you see before what do you say, I mean, while conducting the site assessment, you should also take into consideration that you're going to work at height. So you're going to provide some safety devices. You need to hook some safety devices. So whether there is a provision for hooking, provision for making arrangements to place such kind of devices like lifelines or anchorage points. If there is no such things in place, then you have to identify where you can hook your lifelines or harness to. So all these things shall come under your pre-site survey or pre-installation inspections. Okay. So at the time of installation, the major hazards that these installers will come across is your working at height, where working at height really falls are the major incidents occurring across the world. It is a biggest contributor in construction industry. So we really take much priority over here. And next comes electrocution because of many things. We are going to see why electrocution happens and all. Okay, slip trip falls, if there is any slippery surface, if there is any cables, no proper housecapings, and if there is no proper illumination, you might fall from a height. So slip trip falls are also major contributors. We need to prevent such kind of, prevent this particular slip trip fall. And next is manual handling. You will be carrying lots of weight. Your employees will be carrying lots of weight, and sometimes while you're carrying the way panel, you cannot see what is in front. While carrying some equipment, you cannot see what is in front. So it becomes really difficult for the person to climb to the rooftop by carrying the panels or equipments. Okay. So even if it is a repeated activity, then it might even lead to ergonomical issues. So this is certainly a bigger hazard we need to take care of, and especially the lifting techniques that we have to, persons has to implement. And mechanical lifting, we are using hydras or cranes to take your material or carry your material to the top. So these things has to be inspected, all the belts has to be inspected. There should be no sharp edges, and make sure that this particular belts are, what do you say, placed on the right point. Because if not, what happens is it totally crutches your load. So what happens is there might be a damage even when lifting your load. So we have to take care of that. We have to make sure that the sharp edges are protected. Okay. And next is power tools and hand tools. Whatever tool you are using, what you have to do is you have to inspect it before and after use. Okay, before use you have to inspect, and even after use you have to inspect for any damages. If you find if it is damaged, then you have to send it for maintenance. Okay, like I said, there is no shortcut for safety. You have to be safe. You have to make sure that everything is in its own place. Okay. And here in power tools and hand tools, what you need to do is you need to look for cut or damaged cables, overloaded cables, burns or damaged insulation, guards. If you are using grinding machine, then you have to make sure that guards are in right place, and grinding disc, you have to check the grinding disc RPM and expiry date of your grinding disc. So there are many things, but you have to inspect your power tools and hand tools. But in short, simple thing, what I would recommend is inspect it before and after use. Before use is for your safety, and after use is for your other person's safety who is going to use the tool the next day. Okay, it is not just you are saving yourself, but you will be saving the other person's life as well. Okay. Okay. Next, what are the hazards in post installation? After installation, certainly it's going to be maintenance and operation. In a maintenance and operation, the biggest hazard is either you're overloading the system. In the long run, what happens is it might develop some heat. There may not be proper ventilation. We might not see because at in time of installation it seems correct, but when it is running, you might feel that no, the ventilation is not sufficient for your battery system, be it your battery system, be it your PV system. So you have to make sure that the ventilation is good. And second thing is failure of PV components, because there are electrical parts connected to it. Even a resistor failure or a capacitor failure can turn off the whole equipment. So even we cannot say, we cannot be sure of the reliability of the component. So these are the even that might lead to the failure of the whole PV system. Okay. And arcing is a major hazard, and it is a primary reason for many of the fires occurring in rooftop PV or array PV. Okay, this is the main key factor, because we are having a huge voltage which is being generated in PV panel. So even if there is a small gap between one terminal to other terminal, what happens is the voltage will try to jump from one point to other point, because that is a tendency of electricity. So if the voltage jumps from one point to other point, it creates a flash. So by creating this flash, if it continues, it tends to create arc. And arc, uh, high current passes through the arc, creating heat and fire. Okay. So these things we have to take care of, and this is a very big hazard. So how do we take care of this particular arcing? We have to make sure that there are no loose connections and no short circuits. And faulty wiring. For example, say there is a DC and you need to connect positive to positive and negative to negative. What if a person doesn't know, or if it's not marked properly, if he connects positive to negative and negative to positive, what happens? I'm just giving a scenario. It doesn't need to be exactly positive to positive or negative to negative. I'm just giving a scenario. So if there is a faulty wiring or reverse polarity, what we call it, then there is a chance that there might be a fire there, fire or explosion. If it is a battery, it's certainly going to explode. Okay, so explosion, fires are going to occur because of this faulty wiring as well. Okay, improper system grounding. So earthing is key. Earthing has to be there for every system installed. Okay, and earthing is specifically for person's protection. It is not for equipment protection. It is specifically for person's protection. If the earthing is not good, then it might lead to shock. A simple thing. So we are preventing that. And by providing your proper LCBs or your circuit breakers, we are providing, providing circuit breaker, we are providing safety to the system. It trips when it has a, suddenly jumps a high potential, when it suddenly takes up current, what happens is it trips up. So that's the safety for the system, but for safety for the person, it is completely earthing. Earthing has to be done properly. Okay. So these are the hazards in pre-installation, installation, and post-installation. And second thing we have to say is in maintenance. At the time of maintenance, we need to make sure that the isolations is being carried out properly. So we are going to discuss that next. Okay.
Mr. Verma, sorry to interrupt
Yeah.
you. I think we have 10 more minutes for your presentation. So I would want
Okay.
to directly go to the calculation and then
Fine, fine.
Yeah.
Okay.
Sorry for that. Yeah.
Yeah, sure. Thanks for reminding me. Okay, so our next topic is topic is working at height. So in working at height, we have different hazards. Okay, so basically we have two main hazards, which is fall of material and fall of persons. So to control fall of material, what we can do is we can keep all the tools or equipment, so whatever you are having in a tray, you keep all your tools in a tray. And if you are using it while you're working at height, have lashing, tying a rope to your tool and one end to your hand. Even if it drops, what happens is it just sticks to your hand, so it won't drop down. What if there is a person or any person's working down, and if it hits, it is going to be fatal injury. So fall of material is a great concern, but more than that, fall of man. How do you control fall of persons, okay, while working at height? we have many things. Okay, we have personal forest system and primary forest system and secondary forest system. In primary forest system, we have guardrails. We have discussed about it. And secondary forest system, we have PP. PPE means we have safety harness. With this safety harness, we will be hooking to some anchorage points or lifelines. Okay. So how do we select our PPE? So we have our harness. Okay. Normally harness length is like a harness with a lanyard. So we recommend having a double lanyard system, which is easy for navigating on the rooftops, which won't restrict our movement. Okay, which we can be safe throughout our work time. Okay, even though you're moving from here to there or there to here, it will be safe. So we recommend double lanyard harness. Okay, where the harness has to be hooked to the lifeline or anchorage point, and we call it 100% tie-off, which has to be hooked to that particular point all the time. Okay, so while selecting harness and where we should hook is a very important thing, because even if a person falls from a height, he should not reach the ground. The main goal of having a harness setup or a follower system setup is to make the person hang in a midair. He should not reach the ground at any cost. Okay, so our lanyard, whatever harness we are having, our lanyard length is 2 meters, and we'll have a shock absorber which opens. Okay, and which opens after the fall. Okay, its elongation, it's a shock absorber elongation is 1.75 meter. Height of the person till the d-ring comes at the back of your okay, shoulder. Okay, so the height up to that point is your 1.2 meter, and the safety distance is 1 meter, so that is 3 feet. Okay, so total clearance is 6 meters. That means from the ground level, if you want to use harness, the minimum hooking point is at an elevation of 6 meters. But if you are going to use your follower system, then you see the total safety clearance has to be more than 6 meters. It depends on the swing. Okay, I mean, it depends on the total retraction that you have taken from the follower system. Okay, kindly look at this video. You'll be able to know how to calculate the clearance from platform.
Self-retracting devices, or SRDs, are also often used in fall protection systems because they allow you more flexibility of movement and reduce the free fall hazard because the lifeline is always under tension. In other words, there is no slack in the line regardless of where you tie off. This added flexibility of movement does increase the possibility of swing fall. You'll see this when Abel steps off the platform. The further you walk away from your anchor...
Okay, so I'm just going to explain. You can see now the person has moved from one point to other point. So the length, there is some extraction from the fall harness. So we have to calculate that extraction and make sure that that is calculated to the existing distance. So that will be approximately equal to 10 meters if it is a normal fall system. And everything will be mentioned on the fall block. Okay. And make sure that the hooking point is always above your head, because if it is side by left or right, because of the swing, you'll go and hit the nearby objects. Okay, okay. So with that, we'll just wind up our topic working at height. Now we'll look into electrical safety. In electrical safety, what are the hazards? We have to remember electrical safety hazards, just remember be safe, which is B for burn, C for electrocution, S for shocks, A for arcing, F for fires and explosion. You have all these things in your material. I'm just going to run up fast. So what are the hazards in electrical safety? Okay, in electricity. So, I mean, if you have inadequate wiring, okay, if you're overloading your electrical parts, if there is any damaged insulation, if the electrical wires are exposed to, they are kept on a dry surfaces, or sorry, wet surfaces. you're working close to overhead power lines, you're using ROM PPO tools. If you're, for example, say, what do you say, uh, you are not having proper earthing for the electrical tools. So all these things are the hazards. What are the preventive measures? Protective measures is just to make sure that there is no shock for the person and there is no damage to the asset. So we have to use proper grounding, use ELCBs, which is earth leakage circuit breaker. Okay, and you know that we have fuses and circuit breakers as protection devices for our equipments, and we have to guard the live parts, like insulation has to be proper, termination has to be proper. If there is no loose termination, make sure there is no loose termination, because that is a place where the sparks comes up and it can be the source to fire. Okay. Okay, so whenever you are having this whenever you are doing this maintenance work, make sure you have this lockout and tagout applied. Okay, so lockout tagout is nothing but a simple tool. Okay, where you provide on a circuit breaker or an on-off switch. Okay, to make sure that no other person will operate that particular switch other than you. For example, two or more persons are working on a same line, then three persons has to put the lock on the same switch. So for that we have equipments, we have devices, not a problem. We have hasp lock, we call it. We can we can lock up till 8 persons. So until and unless these 8 persons remove their locks from that hasp lock, that lock will not be removed from that particular switch. Okay, so this is a safety device which comes up, which comes in handy where you are doing isolation, where preventive, where we can prevent the energization of that particular line. Okay, unauthorized energization of that particular line. Okay, right. So the main purpose of lockout tagout is to isolate the energy sources. So whenever you are doing this maintenance part, make sure you have switched off the electricity, you have done this lockout tagout, make sure there is no voltage in that particular section. If there is a voltage, that means it is hazardous. There is a trapped energy, or there is a trapped energy. So you have to discharge the trapped energy and then make sure that there is no voltage, and then you can work on the electrical part. So this is a key safety feature whenever you're doing maintenance. A short video on LO2. Okay, so now the last slide is we have this electrical fires occurring because of electrical short circuits or arcings or overloading. So fire is a chemical reaction between fuel, heat, and oxygen. So if you need to, extinguish the fire, what you have to do is you have to use either CO2 or DCP fire extinguishers for electrical fires. But one thing is you should not use water on electrical fires. No way, because you are going to get a shock. So how do we operate the fire extinguisher? By a short formula of PASS, PASS. First thing is you need to pull the pin, then aim the base of the fire. You have to squeeze the handle and then sweep it side by side. By this, we will be able to extinguish electrical fires. Okay. So always make sure that you identify your hazards properly and then control it. Okay. You do your risk assessment properly, and by implementing control measures, you can keep your work safe. Okay then, and thank you. We will just close this first session with this slide. Over to you, Mr. Atul.
Thank you, Mr. Verma. I think we have a lot to talk, but we are out of time, and hopefully, I think there are a lot of things to talk about, and maybe we have to organize another session to specifically talk about general safety. There are a lot of things. I think it was really interesting for everybody around. Now, I'll just request Himanshu. We are already taken up some time from Himanshu's presentation, but I think Himanshu will be able to cover up. Himanshu,
Okay,
over to you.
sorry for that.
No issues. Yeah, Himanshu, please. Himanshu, am I audible?
Yes.
Yeah, great. Yeah, go ahead. I think you will have to share the slides, Himanshu, when you open the PPT. It's showing your desktop screen at the moment.
Wait. Is it visible now?
Yes, go ahead.
So good afternoon all systems. Now we will discuss about the specific safety aspects in solar rooftop PV systems. So these are the topics we will cover in the next half an hour. Lighting protection, surge protection device, earthing, specific consideration during the installation, and safety consideration during the O&M. So we'll start with the lightning protection. These are the few facts about the lightning. A lightning have an intensity of 100 million volts and 100 kiloamps of current. It can generate a heat up to 54,000 Fahrenheit. Every second lightning strikes somewhere on Earth. Hundreds US resident kills every year due to the lightning. So these are the few interesting facts about the lightning. These are the component of lightning protection. Here mainly we consider 4 components. First one is the lightning rod and the lightning arrestor, this one. Second one is the surge protection device. Third one is the down conductor. And last one is grounding or earthing. So first, lightning arrestor. What does the lightning arrestor do? Let's first discuss. This lightning arrestor is required for a smaller system like 1 kilowatt and 10 kilowatt. A lot of people have these questions. And the answer is yes, it is required. Because the lightning does not have a sense where to strike or where not to. Basically, lightning is just negative charge, or we can say it's a bunch of electrons. So it always attracted by the positive charge. So if your system capacity is a 1 kilowatt, but the surrounding atmosphere have a positive charge, and if the lightning occurs, it may hit your system. So definitely for a single kilowatt system, you must have to use the lightning arrestor. It also depends on the state policy. Many states allow no lightning arrestor up to 10 kilowatts, but in Gujarat it is compulsory for a single kilowatt system. So let's come on to a lot of people have a myth that a lightning arrestor could catch the light, but it is not true. It is just a rod of metal. So it does not absorb the lightning. It does not stop the lightning. It does divert the lightning to ground and limit the voltage produced by the lightning. So it is only function that lightning arrestor can do. It can divert the electricity. It can provide a low resistance path to lightning. Formation of lightning discharge. So again the same question, if we have a number of buildings and lightning occurs, on which building it may strike? So it may strike on the building, but the surrounding atmosphere have a positive charge. So no one can judge where it can strike. It is always depends on the atmospheric condition. Here you can see the designing method of lightning arrestor, or we can say in layman language where to place the lightning arrestor. So it can protect our entire solar PV systems. So the first method is the protective angle method, and standard of compliance is IC 62305.
Himanshu, I think we're losing your voice.
See in the first picture. A lightning arrestor. Is it audible now?
A bit better. I think your Wi-Fi had some problem. Maybe you can start now. Yeah.
Maybe. So in first picture, you can see a lightning arrestor provide a 45 cone of protection. This one. And in second pictures, you can see a large structure can be protected with the multiple row with overlapping zone of protection. So you can always use this method to design your lightning system. The second method is rolling sphere method. This method we consider one imaginary sphere. You can see here. This is your sphere. And the radius of sphere is depend on the light intensity of light. So here we can calculate the light. Here we calculate the height of the rod and the distance between two rods. So this is the lightning arrestor and this one is the lightning arrestor. So we can calculate the height of this rod and the distance between these two rods. These both methods are using in the PV solar rooftop systems, but normally we are accepting a angle method because it is easy to design. Second component, it's the SPD surge protection device. Basically, it is a MOV, metal oxide variator. It's a kind of voltage operating switch. Here you can see connection of SPD, positive, negative, and earth. Here you can see positive, negative, and earth. So if there is a AC SPD, phase, neutral, and earth, and it is DC SPD, then positive, negative, and earth. This is the fuse with the green indication. Indication becomes a red while it blow out. So we have to replace the fuse when it blow out. So this is the connection of SPD and how it works. So here you can see a normal house wiring with the proper grounding. The voltage is 230. If the lightning hits this house with the intensity of 100 kiloamps, and we consider a ground resistance of 1 ohm, so it will produce. Now phase have 230 volts and neutral have a 100 kilowatts. So there is a large potential difference between phase and neutral, which can generate and pass a large amount of current. So the appliances are blowout. Now to avoid these circumstances, we will put a switch called SPD between phase and neutral. So we will put a switch over here, phase and neutral. So whenever SPD sends a high voltage, it will operate automatically. It will short phase and neutral for a while, and phase and neutral both comes in an equal potential. So the current will be 0. Meanwhile, earthing discharge the current in the earth or in the ground. It is always connected in a parallel with application and with the equipment. So this is the use of SPD, surge protection device. These are the standards followed by designing IC 62305 and for earthing IEEE 80. Both side SPD is required, AC and DC. Earthing, the purpose of earthing is to provide a low resistance path to a fault current, and it is used to protect the human body from an electric arc, electric shock. In this picture you can see there is a fault current or leakage current passes through the electrical equipment, and the grounding, if this grounding is not properly, the current passes through the human body. So the human may get shock. But if the earthing is proper, then the current passes through the earth cable or the neutral cable. earthing in solar PV systems. There are 3 separate earthing is required for solar rooftop PV system. One is DC earthing, second is AC earthing, and third earthing is for lightning arrestor. DC earthing is required for solar panel, DC junction box, or DC distribution box, or DC array combiner box, and solar PV structures. AC earthing is required for inverter and AC distribution box. And third, separate earth pit required for the lightning arrestor. We have to maintain the 3-meter distance between the earth pit. Here you can see this distance is more than 3 meters, 3 or more than 3 meters. AC and DC earth pit should not be interconnected with each other. It must be separated. यहाँ पे दोनों earth pit को internally connect नहीं करना है. It must be separated. So here you can see structure earthing and the PV modules earthing. Normally we all are doing the structure earthing, but in solar PV rooftop and ground mounted, it is compulsory to earth each and every solar module, because the frame of solar module is it's a anodized aluminum. So ionized aluminum, it acts as an insulator. So you have to connect each and every panel through bonding, and then you have to connect it to grounding or with the structure. Maintenance free earthing. Maintenance free electrode is designed as per the IEC 3043 1987 standards. Some of the features of maintenance free earth electrodes: it is ensure a maximum conductivity, it contains a highly conductive compound, it is a corrosion free and highly rust resistive, least variation in ohmic value, and large surface area to carry a large fault current. Soil resistivity improvement powder. So in conventional earthing, we use the salt and charcoal to reduce the soil resistivity and to reduce the ohmic value. Here in maintenance free earthing, we are using a soil resistive improvement powder, which is non-corrosive and absorbing and retaining the moistures. So in conventional earthing, what we can do, we are using a plate of copper and or GI, then we go with the soil and charcoal. Here we are using a soil resistivity improvement powder. These are the maximal permissible resistance of earthing systems. So low power station 0.5 ohm, major substation 1 ohm, small substation 2 ohms. In all other cases like solar rooftop 5 ohms, and each continuity inside the installation 1 ohms. Safety during the installation. Always use a proper PPE like helmet, electric gloves, and the safety shoes. Always work as a team of 2 or more. So any accident occurs, one can call the emergency team. Always open a cartoon at the time of installation only, because sometimes scratch comes on the glass during the storage and transportation, which may increase the reflection index, which may decrease your panel output. So do not open the cartoon until installations. Then, during installation, do not touch the PV module unnecessarily, because glass surface and frame may hot, so there is a risk of burn. If the module is damaged from somewhere, so there is a chance of leakage current and risk of electric shock. Again, your fingerprints on glass may increase the reflection, so the output of panel may decrease. Sometimes we damage a module when replacing the PV module by clamming on nearby modules. So never clamp and sit and stand on the PV modules. Sometimes we damage the back sheet of modules when fastening the PV modules to support by the bolts. Or the overtorque may damage and bend our module frames. always use a conduit or a raceway to lay the cable on terrace. So the direct sunlight will not expose and prevent degradation of cable insulations. In first picture, you can see cable is secured fastened to the module frame. In second picture, you can see cable is in second picture, cable is laying through the cable raceway or cable tray. And in third picture, you can see there is a footstep which can protect cable tray. And do not unplug MC4 connector under the load condition, because we are dealing with the 8 to 9 ampere of current. So it creates arc and there is a chance of electric shock and burn. So never do it. Keep the AC and networking cable separate. So the electromagnetic interference may induce the noise in the network cable. So it may get the wrong data. So you may get the wrong data. So never. So keep an adequate distance between your power cable and the network cable. Do not wear a metallic jewelry like finger rings, bracelet, even a metal watch. It may conduct electricity and enable to electric shock during the installation. You can always use insulated tools. Safety labeling. Each and every electrical component must be labeled as a PV array DC isolator, PV system main AC isolator, electric shock risk, and contain a live pipe during the daylight. So the person who is not familiar with the PV system can read and understand the risk of hazard. Then this is the shutdown process for the O&M. Step 1, switch off the AC isolator, which is next to the inverter or placed in the AC junction box. This one. Step 2, switch off the DC isolator or remove a DC disconnector placed in the DCDB or DC array combiner box. This one. Third step, if your inverter have a DC disconnector or DC isolator switch, flick this switch to the off position. If you do not have, skip this step. And the fourth, to restart a system, follow the guidelines in reverse order. Like first, switch on the inverter DC switch, then DC isolator, and then AC main switch. Again, AC isolator and DC isolator switch off करने से आपका मॉड्यूल पावर जनरेट करना बंद नहीं करेगा. If you want to stop the generating power from the modules, then you have to cover the modules. Otherwise, in low light, it produces a voltage. O&M consideration during the safety. Solar panel became extreme hot in sunshine and generate a large amount of current. So to avoid the risk of electric shock and burn, either clean your panels in the morning before 11 AM or late evening after 5 PM. Always use a proper measuring device like a multimeter and clamp-on meter. Do not use a tester and test lamp to check the voltage. Implement a circuit lockout and tag out rules, which already have been discussed by Mr. Verma with wonderful videos. So we will not discuss more about it. So we will move to the next slide. So inverter have a large number of capacitor that could hold a charge even after the power source is removed. So wait at least 10 minutes to allow a full discharge of internal capacitors. Or even you can follow a manufacturing guidelines. Then no socket outputs are permitted from the inverter output. कई बार ऐसा होता है कि इन्वर्टर के फैन को ब्लो करने के लिए और ब्लोअर लगाने के लिए जो इन्वर्टर का आउटपुट होता है वहीं से हम 3-फेज सॉकेट लगा के वहीं से हम पावर लेते हैं, तो वो नहीं करना चाहिए. So an electrical arc phase hazard exists while adding and removing the fuse. So always use a fuse puller or electrical insulated gloves for adding and removing a fuse and a series of solar PV panels. All extension equipments are protected by the ground fault circuit interrupters like ELCB and RCCB. That's it. Thank you. Over to you, Atul.
Thank you, Himanshu. Thank you so much for this detailed technical presentation. I think we had a lot of topics to be covered today, and I think 1.5 hours was not sufficient. We plan it in a way that maybe we'll have to do another couple of sessions on this subject. And as Mr. Verma rightly said, I think even if a lot of installers are already here, and I think many of the small installers have joined us from across the country, and you might be thinking about ISO, Mr. Verma actually emphasized on. So as Mr. Verma rightly said, when we talk about ISO, when we talk about specific implementations, I don't think you as a small company need an ISO until you can practice the same aspects of safety on your own. You can plan it in a way where you can have your own internal policy, you can have your own plan, and you can execute to start with. And with this, actually, I would like to share a small thing that EU has developed a hazard identification checklist. This is available online on the osa-europa.eu. I will be sharing the link with you. This is prepared by the European Union Information Agency for Occupational Safety and Health at Work. This particular checklist or document is associated with small-scale solar energy applications, and it will give you an insight on how you can create your own prevention document for prevention from accidents and damages to health in solar energy sector. And also the checklist can be used by your internal assessment team to identify hazards in the complete implementation of this solar PV applications. So we'll be sharing the link and the document with you to all the attendees after the webinar. I think this could be helpful as a first step for you to understand the subject and make it into the practice of your life. Yes, I think Madam Ms. Dubey is here with us, and maybe she would like to have some closing remarks on the subject. Over to you, Madam. Ma'am, I think you will have to unmute yourself.
Yes. Yeah, yes. I could do it. Yeah. I think the information given on the safety of personnel working during the installation and also during the operations is of very high, is useful for all of us who are attending the webinar. I hope everybody has liked it and now know how important it is for the installations. In any, if anybody wants any other, I mean, I have to take permission from the European Union before I say this.
Yes.
Okay, if people want more and more such trainings, then they can come forward, and that is all for today, I think. I'm just giving this thing to Mr. Dheer to complete. And before doing this, I'm thankful to all of you to be amongst us and to take advantage of this webinar.
Thank you.
Over
Thank
to
you
Mr. Dheer. Yeah.
Thank you, ma'am. And I think the subject we have tried to put in together the very important and neglected subject. And this has been the first webinar which was related to subject. I think I've seen the kind of interest we have got. We've got more than 100 participants sitting around and listening to us patiently. So I think maybe we'll come up with another set of webinars technically, and maybe another series of webinar on different topics on safety as well. And I see a lot of people have put in some questions, and the common question is that you want to have the presentations. You all will receive an email with the two things. You will have the checklist from prepared by the EU on safety, and you will also receive an handout prepared by Mr. Verma specific to solar PV applications. And another thing, we'll be sharing a Google form where we'll be requesting your feedback out in this webinar. I think with your feedback, we'll be able to learn better and organize the webinar better and organize various other subjects. Also, there is a poll in the poll section. If you wish to participate, you can answer a few questions, and maybe you can also advise us the next topic of the webinar you would like to participate in. With this, I think thank you everyone for participating. Thank you, madam, for your precious time for these 2 hours being with us, and all the attendees. We'll be keeping in touch with you. We'll be sharing all the details, and I think we'll see you soon on the next webinar in 2 weeks. Thank you so much for participating.